Beginning today, SupplyPoint announces a paradigm-shifting supply chain solution that does not exist anywhere else. Our specific, proven technical innovation re-engineers the manufacturing process for machined parts. Machined parts that used to take several months or more to design, produce, and deliver are now machined in just weeks. SupplyPoint has fundamentally changed the manufacturing method, eliminating the time-consuming barriers between design and production. The SupplyPoint innovation drastically reduces setup times, spindle run times, and lengthy lead times for spare parts. These efficiencies realize double-digit cost savings at every step of the manufacturing process. Most importantly, the entire sector of U.S. small and medium-sized machine shops can now effectively fulfill DoD needs. This is the heart of the SupplyPoint innovation, and it will change everything. For more than half a century, the Defense Department, defense contractors, and the manufacturing community have been locked in an urgent, precarious, and worsening relationship that compromises our warfighters' readiness to respond. This failure cripples our ability to respond to surge demands and debilitates maintenance, overhaul, and repair of war material. Coupled with this crisis is the frustration of manufacturers who want to step up but can't. Presently, our defense manufacturing base for machined parts is inefficient, marked by the excessive waste of labor time throughout the entire traditional design-to-production cycle. The traditional design-to-production process requires a designer to convert blueprints to 3D solid models using computer-aided design or CAD software. Working from blueprints, oftentimes designers may not have the technical experience to detect inaccuracies, thus creating 3D models which result in faulty or unmillable parts. After the designer has finished the 3D solid model, the model is sent to the tooling department where a manufacturing engineer identifies the tooling and fixturing for the part. By identifying and designing the fixture and holder before determining the best tool paths, the programmer is committed to a machining process that limits their options in determining the optimal tool path for machining. The result is that machining a part may include excessive CNC machine setups, incorrect tooling, excessive labor, and scrap material. Once the fixtures have been identified, programmers use computer-aided manufacturing or CAM software to select the tools and tooling paths based on the features provided in the 3D solid model to be used to manufacture the part. This creates a process plan that describes how a part is to be machined. The process plan will be used to generate the G&M codes for specific CNC machines. Unfortunately, few programmers have post-processing software scripts that automatically convert the process plans into the G&M codes specific for the CNC machines to be used. And too often, these post-processing scripts are not fully optimized for the specific CNC machine controller combination. The final step in the traditional process is for the CNC machine operator to validate the CNC machining codes to be used for production. A failure in this step requires designers and programmers to restart their efforts, often resulting in weeks or months-long delays. What we have described is typical for a machine shop. There's one more liability in the current process: lack of revision control. In traditional machine shops, designers, programmers, and machine operators are often siloed from one another, and each may be making changes to the part throughout the manufacturing process. However, there is no systematic approach to capturing the modifications, no revision control. So some parts, even successfully manufactured parts, do not reflect their updated specifications. In the absence of a breakthrough technology that eliminates the barriers and inconsistencies between design and production, we will continue to see excessive production costs and be unable to fulfill surge demands and backordered parts for the warfighter. SupplyPoint is that breakthrough technical innovation. SupplyPoint is a comprehensive end-to-end rapid turnkey production solution that eliminates the barriers and inconsistencies between the design and production phases in CNC machining. This results in significant reduction in labor cost and lead times while optimizing quality. SupplyPoint accomplishes this by incorporating over 25 years of knowledge, machining intuition, and best practices in geometric tolerance definition, machine operations, tooling, material selection, speeds, feeds, and fixture design to ensure design for manufacturability at all stages from design to production, and using a single CAD/CAM post-processing platform to record and maintain revision control. Embedded in this single CAD/CAM post-processing platform is the following intellectual property: SupplyPoint Advanced Technology Database of tools, speeds, and feeds for all CNC machines currently in use. Post-processing script files on over 1,400 combinations of CNC models controllers currently in operation. The SupplyPoint approach is simple. Blueprints are confirmed for accuracy and geometric tolerances before conversion to 3D solid models. The SupplyPoint Advanced Technology Database and machining intuition are applied during the CAM process to determine the best tooling, speeds, feeds, and quality probing prior to developing the process plans. The toolpath is virtually simulated to ensure accuracy and to avoid crashing of CNC machines or breaking of tools which are costly to replace. Fixtures and holders are designed after determining the best toolpath. Designing the fixtures and holders after determining the best toolpath effectively reduces the number of machining setups, setup times, and machine run times. A post-processing file is executed to generate the G&M codes for the selected machine and controller. Electronically transmitted G&M codes are generated and validated on one of our machines to produce the part. The end product of this effort is a part and machine-specific turnkey rapid production package that includes complete and proven-out process plan, SupplyPoint 3D solid model, setup instructions, part-specific G&M codes with advanced macro-parametric scripts. The turnkey rapid production package is electronically archived and continuously updated to keep pace with technology advance. Most importantly, using SupplyPoint's unique post-processing scripts, a turnkey rapid production package can be recompiled for any one of the 1,400 CNC controller combinations, ported from CNC machine to CNC machine of differing types. This conversion takes minutes. With access to 4,800 CNC machines in 800 shops in 25 states, SupplyPoint has effectively created the largest virtual machine shop in the world, able to respond to surge demand and supply chain disruptions on a moment's notice. In the traditional model, it takes 50 to 100 man-hours for machine shops to finish the completed setup sheet to formulate a bid. For many small and medium-sized machine shops, this step is cost-prohibitive. After implementing the SupplyPoint innovation, SMEs now only need to complete 3 items to bid: overhead costs, labor costs, and material costs. The result is that the entire sector of small and medium-sized machine shops can rapidly be brought to bear on DoD procurement opportunities. SupplyPoint has proven the concept again and again. Here are examples. For the suspension arms of the M119 howitzer, SupplyPoint achieved the following efficiencies: condensed 17 setup operations to 5 setup operations, reduced setup time from 65.5 hours to 4.5 hours for the 5 operations, reduced spindle runtime from 19 hours to 5 hours, reduced lead time from 6 months to 2 months, used 3 newly designed fixtures, eliminated 8 CNC machines, projected reduction in production cost by $8,000, projected savings of $4.8 million over 10 years. For the M250 caliber machine gun barrel extension, SupplyPoint achieved the following efficiencies: reduced machining operations from 12 to 4, reduced setup time from 40 hours to 10 hours, reduced number of CNC machines from 3 to 1, reduced special tooling requirements from 5 to 2, projected reduction in lead time from 9 to 18 months to 3 months, Projected reduction in production cost from $687 per unit to $378 per unit. Projected savings of $31 million over 10 years. Delivered parts for the M1 Abrams tank in 28 days after the request, slashing the usual 6 months to acquire through traditional channels. For the critical sub-assemblies for the Boeing 737 latch on cargo doors, SupplyPoint achieved the following efficiencies. Reduced setup operations from 6 to 3. Reduced setup time from 11 hours to 30 minutes. Reduced spindle runtime from 114 minutes to 45 minutes. And projected labor cost reduction by 90%. For 7 critical complex items for heat exchanger and condensers used on M1 tanks and F-18 fighters, SupplyPoint achieved the following efficiencies. Projected average machining setup time reduction improvement of 33%. Machine runtime reduction average improvement of 46%. And overall machine processing time improvement of 25%. SupplyPoint is a game-changing supply chain solution. By using a single CAD/CAM post-processing platform, SupplyPoint fundamentally changes the manufacturing method for machined parts. SupplyPoint is the rare triple win. Legislators ensure the best value for taxpayer dollars while creating thousands of skilled, well-paying jobs. Defense officials get spare parts to warfighters much faster, ensuring surge and mobilization capabilities. And small and medium machine shops can now be fully integrated into the DoD supply chain. This is the heart of the SupplyPoint innovation, and it will change everything. SupplyPoint, how tomorrow works.